Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on radioactivity and standard model for March 2022, paper 2, variant 2. In this lesson, we will discuss what are leptons and what kind of leptons are produced in any beta plus decay. Then we will talk about nuclear number and proton number. We will also discuss what are baryons, what is the quark composition of baryons, and how we can determine the charge on baryons. For part A, it is given to us a nucleus of sodium-22 decays by emitting a beta plus particle. A different nucleus is formed by the decay. We need to state the name of an other lepton that is produced by the decay. Question is asking us to state the name of an other lepton. If you look at this beta plus particle is positron, and positron is antiparticle of electron and it belongs to lepton family. So this is the first lepton that is already given to us, and question is asking us to state the name of an other lepton that is produced by beta plus decay. And let's try to understand first of all beta plus decay. So here we have sodium nucleus, its atomic number is 11 and mass number is 22, and this sodium nucleus, it decays by beta plus. So simply we can say another nucleus is formed. Let's say that nucleus is Y and beta plus particle is emitted. So here we have beta plus particle, and here it has to be electron neutrino. Why this one has to be electron neutrino? Because this particle is positron and positron is antiparticle of electron. So this is antiparticle of electron. It has lepton number -1, -1, but this nucleus, it has 0 lepton number. So in order to conserve lepton number, this has to be electron neutrino. So simply the reason is that if this one is beta plus particle, this has to be electron neutrino to conserve lepton number, and vice versa is also true. If this is particle, means if this is electron, this one has to be electron anti-neutrino. You have to be very clear about this point because they will ask you this in many ways. So we can say this is positron and positron is antiparticle of electron. So this is antiparticle of electron. And this is electron neutrino. So this is electron neutrino. There are different types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. That at AS level only you need to understand electron neutrino. So in answer, you can write down electron neutrino, but still you will get mark if you only write down neutrino. Still you will get marks. So better to write down is electron neutrino, but if you only write down neutrino, still you will get the mark. So this is the mark. Next question is asking us to determine the nuclear number and proton number of the nucleus that is formed by the decay. This is beta plus decay, so the proton number will decrease by 1. So here atomic number means the proton number has to be 10. 10 plus 1, 11. It has to be same on both sides, means proton number has to be conserved, and mass number will not change. So this will be 22. Mass number is nuclear number, so we can write down here 22 and this one is 10. And also we need to understand is, if you look at this beta plus decay, very important point, if you look at these two particles, they belong to lepton family. So you have to be clear about this one. These two particles, they belong to lepton family and they do not feel the strong nuclear force. Lepton, when we talk about leptons, it means we are talking about lighter particles. So these are lighter particles and they do not interact with strong nuclear force, or simply we can say they do not feel strong nuclear force. They do not feel strong nuclear force, or they do not interact with strong nuclear force because leptons are not present in the nucleus. And this question has 2 marks, so these are answer marks. If you have written 22, you will get 1 mark, and the second mark you will get if you have written 10, means the proton number. For this question, it is given to us the quark composition of a nucleon in the sodium-22 nucleus is changed during the decay. We need to describe the change to the quark composition of the nucleon. So first of all, let's try to understand what is nucleon. Nucleon simply means that any particle in the nucleus. So simply we can say nucleon means any particle in the nucleus is named as nucleon. Any particle in the nucleus is called nucleon. So simply we can say any particle in the nucleus. In the nucleus we have protons and we have neutrons. So protons and neutrons, we call them nucleons. Let's try to understand a little bit more about beta plus decay to answer this question. First, we will start from sodium. Sodium 22 means the mass number of sodium is 22 and atomic number of sodium is 11. This decays to a daughter nucleus by beta plus decay, or simply we can say by emitting beta plus particle and electron neutrino. This daughter nucleus, it has atomic number 10 and its mass number is 22. Now we need to understand mass number first of all. We will look at this mass number. So here is also the mass number. If you look at this mass number, sodium has 22. The mass number of sodium is 22 and the mass number is the sum of proton and sum of neutron. And daughter nucleus, this also has the same mass number 22 and this is also sum of protons and neutrons. Sum of protons and neutrons. Atomic number is 11. It means we have 11 protons here. Neutron number is 22. So 22 minus 11, it means we have 11 neutrons as well. 22 minus 11 is neutron number. But if you look at this daughter nucleus has atomic number 10. It means it has only 10 protons. So neutron number in this case is 12. So if we look at neutron number, we can see neutron number is increasing. So if the neutron number is increasing and if you look at the proton number, this one is decreasing. So we have minus 1 here. Proton number is decreasing. The neutron number is increasing. So it simply means that in this case, one proton changes into neutron. So we can simply write down in this case, one proton decays into neutron. So this is one thing you can write down. Proton decays to neutron. And the quark composition of proton, it has 2 up quarks and 1 down quark. And neutron has 1 up quark and it has 2 down quark. Describe the change to the quark composition. So simply we can say in this case 1 up quark decays to down quark. So simply we can write down in this case up quark changes to down quark. We can say up quark changes to down quark. And that is the change in quark composition. Up quark changes to down quark. And this question has only 1 mark. So this is the 1 mark. Kind of typical question you need to understand. I have explained this one in detail, but if you are very clear about this one, so beta plus simply means that proton decays to neutron. If it is beta minus, then neutron decays into proton. For part B, it is given to us a baryon consists of quarks that are the same flavor, same type. Means all of them, they are same type of quark. Means all of them, they can be down quarks, they can be anti-down quark, they can be up quarks, they can be anti-up quark, and so on. It is also given to us the charge of the baryon, that is negative 2e. This is the charge on single electron. For part 1, we need to calculate in terms of E, the charge of each quark. The first thing we need to understand is that we need to understand what is baryon. So very important one. If you don't understand what is baryon, maybe it will be quite difficult to answer this problem. First of all, let's try to understand what are baryons. Fermions, I will start from fermions. Or simply you can say matter and antimatter. So fermions consist of matter and antimatter. Fermions can be classified into 2 classes. We classify them into hadrons and lepton. They can be classified into hadron and leptons. Hadrons can be classified into baryons and mesons. Baryons and mesons. Baryons consist of 3 quarks. They can be quark or they can be antiquarks. Consist of three quarks. Mesons, they consist of quark and antiquark. Means one of them will be quarked and other one will be antiquark. So mesons, they consist of two quarks. One quark, one is antiquark. So meson consists of two quark and antiquark. So we can simply write down they consist of quark and antiquark. But baryons, they consist of three quarks. Hadrons, they feel the strong nuclear force. So we can say feel strong nuclear force. I'm using SN for strong nuclear force. Leptons do not feel strong nuclear force. Do not feel SN means strong nuclear force. Hadrons are heavier particles, so we can say they are heavy particles. Leptons, they are lighter particles, so we can simply say lighter particles. Examples of leptons are electrons and neutrinos. So simply we can write down here electrons and neutrinos. So these are examples of leptons. If you look at examples of baryons, baryons consist of three quarks. So the examples of baryons are protons and neutrons. So simply we can say neutrons. Let's try to answer part 1. For part 1, we need to calculate in terms of E the charge of each quark. But now we understand each baryon, it consists of three quarks. So simply we can say in this case Q is the charge on single quark. So the total charge 3Q, this has to be equal to negative 2E. From here we can find out Q, this one will be equal to negative 2 by 3E. So this is the charge on single quark of baryon because it is given to us baryon consists of quarks that are the same type, means all of them, they have the same charge. So this is the charge on each quark of baryon if the total charge on baryon is equal to negative 2E. So this is our answer for this question. And this question has 1 mark and this is answer mark. If you have got this right answer, you will get this mark. For the second part, we need to state a possible flavor or possible type of the quarks. But we have already determined the charge on each quark. So this is the charge on each quark. Now we need to find out type of quark. For this one, we need to understand different types of quarks. So we will start from up quark. So we have first one is up quark. We use small letter U, the symbol for up quark. And in the first generation, we also have down quark. And symbol for down quark is small t. The second generation means after up and down quark, we discover charm quark. This is charm quark. Charm quark and strange quark, they belong to second generation, so strange quark. After charm and strange quark, we discover top quark. Symbol for this one is small t. Top and bottom, they belong to third generation. Mean first we discover up and down quark, they belong to first generation. Then we discover charm and strange quark, they belong to second generation. Top and bottom were discovered at the end, so they belong to third generation. Top and bottom. Symbol for bottom quark is B. Now if you look at the charge of these quarks, charge on these quarks. So this is first, second generation and this one is third generation. Now we need to look at the charge on these quarks. If you look at charge on up quark, charm quark and top quark, you can see something higher, up, charming, top, something better or something higher. So all of them, they have charge plus 2 by 3E. So this is the charge on all these quarks. They have the same charge. Now if you look at this bottom row, all the quarks in this bottom row, they also have the same charge. And the charge is equal to negative 1 over 3E. Means the charge on down quark, charge on strange quark, and charge on bottom quark is equal to negative 1 over 3E. There is a way to remember the charge on these quarks. If you look at this top row, all the quarks in this top row, they sound, the name sounds something higher, like up, like charming, top. They sound something higher. So that's the reason the magnitude of charge on these quarks is higher and positive. Higher and positive. So I will say higher and positive. If you look at this bottom row, down, something down, strange, doesn't sound good. Bottom also lower. So all these quarks, they have lower magnitude of charge and charge is negative. So this is one way you can remember. Now let's try to answer this question. Now we need to state possible type of quarks. If you look at top quark has charge plus 2 by 3e, anti-up quark charge negative 2 by 3e. Now if we talk about anti-chum quark, charge on anti-chum quark will be negative 2 by 3e, and the charge on anti-top quark, that also will be equal to negative 2 by 3e. Now for this question you can say anti-up quark, anti-up, we can say, you can also say anti-chum quark, you can also say anti, I will be writing here, you can say anti-top quark. So you can mention any one of them, you will get 1 mark, and that mark is B mark. So you will get B mark for this one.